Welcome to the new chapter of quadratic equations. This is chapter 4 of class 10, and you can always find the textbook for it in ncert.nit.nic.in. Please download the book. Let us start. But first of all, what we will do, we will just try to delve into concepts of quadratic equation. So starting from the basics, let me write one equation which is a general form of quadratic equation. Okay, let us try to look into it in more detail. So here you can see that, okay, this is A, and here is B. These all are numbers, and then this is C. These all are called coefficient. Why? Because they are coefficients of, here A is coefficient of x square, B is coefficient of x, means it is attached or maybe product with x, okay, and then C is again a number which is a kind of constant or a number. It could be negative or positive, any number. So when we are telling that this is a form of quadratic equation, what does that mean? It means that and whether A, B, C could be 0 or non-zero. So basically the quadratic equation by its definition should contain non-zero value of A, means x square should be present, whether the coefficient is in positive or negative doesn't mean anything, but x square is mandatory, means it has to be there. And what about this x and b? B may or may not be equal to 0. So B could be 0 or B could be non-zero also. And the same with C also. So the only condition which is put for this to be quadratic equation is A should be non-zero. Okay. So, okay. So let us take one example which is also in this book. Example 2. This is just an example, not exercise. So what it is saying, check whether the following are quadratic equations. Okay, so let us take number 1, where it says this is an equation, x minus 1 whole square plus 1 is equal to 2x minus 3. So we need to check whether this is a quadratic equation or not. Okay, let us proceed. First of all, what did we learn in the beginning? In order for this to be quadratic equation, there should be non-zero value of A, means x square should be present. It should not disappear. That is the only condition. And you also know about the exponent, okay, and degree. So quadratic equation is a second degree equation. Second degree means any number, be it x or whatsoever, to the power 2, that is second degree. Okay, so let us try to see this equation. So this equation could be written as x square minus 4 x plus 4 plus 1. So how did I derive that? This is just x minus 2 whole squared. Okay, plus 1 is equal to 2x minus 3. Let us try to simplify. Here is the x square minus 4x. Take this here, minus 2x, and then this and this will become 5, and here it's minus 3, so maybe it will come this side and will become plus 3 is equal to 0. Or we can write x square minus 6x plus 8 is equal to 0. Okay, so this is very close to this equation. Okay, and then what we find here, that a is basically 1, b is equal to minus 6, c is equal to 8. And then for this to be quadratic equation, what is the condition? A should be non-zero. And this is the case. A is non-zero here. So this is a quadratic equation. Okay. Let us take one more example. Examples are very necessary, because what it does, it clarifies your concepts. So let us take part 3 here, which says we need to check this equation, whether this is a quadratic equation or not. Okay, maybe just looking at it, we can easily say that, okay, here this is x squared, so x squared is present, so it will be quadratic equation. But no, we need to simplify it, try to make it in the form of ax squared plus bx plus c is equal to 0, and then only we need to say. So let us take this up. So this is 2x squared plus 3x is equal to x squared plus 1, or these two together, x squared plus 3x minus 1 is equal to 0. Okay, so here also a is 1. There's nothing, means it's 1 times x squared. So a is 1, b is plus 3, c is minus 1. So this is also a quadratic equation. Why? Because a is not 0. Okay, a is 1 here, and it is a second degree equation. Let us take some problems of exercise 4.1. Okay, we will not take all the problems, but let us take maybe one or two problems. Okay, so let us take the third one of the first part. So it says we need to check whether the following are quadratic equation or not. Okay, so the third equation is x minus 2 multiplied by x plus 1 is equal to x minus 1 multiplied by x plus 3. So this is what we need to check. So first of all, we will just try to simplify it and try to bring it in the form of ax square plus bx plus c. But before we do that, let us try to multiply it. So x square minus 2x plus x minus 2 is equal to x square minus x plus 3x minus 3. But what we see here, that here also it's 1 times x square, and here also 1 times x square. So they could be cancelled because they are on opposite sides of the equation. And then minus 2x plus x will be minus x, and then this is minus 2, and here it's plus 2x, and here minus 3. I'm just doing it stepwise. I'm not jumping from here to here, here to there. That's why, uh, in order to avoid any mistakes. Okay, so now minus x, bring it on another side. So 2x plus x. Okay, and then here it's minus 2, and then bring this minus 3 this side. So here it becomes plus 1 is equal to 3x. Okay, or we can also write 3x minus 1 is equal to 0. So here you see there is no x square term. So quadratic equation is ax square plus bx plus c is equal to 0, where x square has to be present. But there is no x square, or we can write that 0 times x squared plus 3x minus 1 is equal to 0. This is as close to this form as we can get it. Okay, but there is no x, there is no non-zero a is 0. It means this is not a quadratic equation. Okay, so initially, whatever may be the form of this equation, you always have to convert it to ax squared plus bx plus c, and then evaluate on the basis of whether a is non-zero or not. And what is a? A is coefficient of x square, or the second degree. X, here you see in this quadratic equation, x is the variable in a way. Okay, so it could be anything. You can write x or t or p or whatsoever. Let us take one more example here. Let us take 7, question 1, part 7, and here it says x plus 2 to power 3 is equal to 2x x squared minus 1. We need to check whether this is a quadratic equation or not. Okay, so this looks like a little bit um, different kind of, or maybe little lengthy, not I would not say different kind, but it's a kind of lengthy questions. And for these lengthy questions, you should be very, very careful about not making mistakes of plus or minus or something like that. Okay, so whenever you are attempting that for any exam, so just keep in mind that you need to give sufficient place to solve that problem, and you need to do many calculations. So just do that calculation separately in a space, and how I will show you how to do that. Let me just do that calculation in red color. First of all, we know that x plus 1, x plus 2 plus x plus 2, this we know. So x square plus 4x plus 4. Okay, and then again it's multiplied with x plus 2. So let us do that. X cube plus 4x square plus 4x plus 2x square plus 8x plus 8, isn't it? Added together, x cube plus 6x square plus 12x plus 8. Okay, so this side we can also write here, or we can express it as this one. Let us write it down here. x cube plus 6x square, all are plus, so 12x plus 8 is equal to this side, what it is, 2 times, so this is 2x to power 3 minus 2x, okay? Or here we see that x cube, we can bring it this side, then it will be minus x cube, so these two together will become x cube, and then this is, let us bring it on this side, 6x square, so we got rid of this one also, and then if we bring plus 12x this side, then it will become minus 12x, and with minus 2 it will be minus 14x, and this plus 8 will be equal to minus 8, and then we are not left with anything here. Okay, so okay, I think we have already solved it, but okay, let us write it this side is equal to 0. Okay, doesn't matter. Now here you cannot say that okay, x squared has non-negative or non-zero number, that's why this is quadratic equation. Another very important, or I should say most important criteria of quadratic equation is that x squared should be the highest degree. There should not be any higher degree than x squared in any quadratic equation. So because of that, this is not an quadratic equation. So this is not quadratic equation. Okay, let us go further. Let us take this question number 2 of exercise 4.1. So it says that it is giving us, it's a kind of text question. Represent the following situations in the form of quadratic equations. Okay, and then in the first part it says the area of a rectangular plot is 528 meters square. Let us make a rectangular plot. Okay, so this is a rectangle and its area is 528 meters square. So whenever we are making solving any problem, you should just write down all the facts which are given in the question. Then it will help a lot in this thinking or for solving the problem. Okay, the area of a rectangular plot is 528 meters square. We have already written down here. The length of the plot in meters is one more than twice its breadth. Okay, so now it is getting a little complicated. So rectangle has obviously length and breadth, and length and breadth multiplied together gives us area. Okay, but it is telling that length of the plot is one more than twice its breadth. So what is twice its breadth? 2 times breadth. But length is not equal to 2 times breadth. It is 1 meter plus than the twice its breadth. Okay, so in that way L is expressed in terms of breadth is 2b plus 1. Okay, so L we can write 2b plus 1. So then now this is what it was, area is equal to 528, isn't it? And then L we can replace by this one. So 2b plus 1 times b, length times breadth, is equal to 528. And then just try to multiply this. We can also write or here. So 2b square plus b, and you can also bring this plus 528 this side, minus 528, then it will become 0. And then you see this is a general quadratic equation, so it is expressed in the form of quadratic equation. Okay, and then very easily do we need to find this breadth? We need to find the length and breadth of the plot. Okay, so we need to find the length and breadth also of the plot. So how to do that? Actually, till now I have not explained how to find the root of quadratic equation. We can try to we will see it later, because there are lots of questions later, but I just want to explain about the roots of quadratic equation